So at this point, we've covered pretty much everything there is to know about the basics of working in the shell. And we'll use just a few more minutes to go over some more tools that are available to us. So these tools could be considered part of a good developer's toolbox. So let's go back into our demo directory. And let's take file 1 and copy it and manipulate it a little bit. So now instead of living in a yellow submarine, let's live in a purple submarine. Why not? And we'll declare that the walrus was Paul, which for those who know their Beatles trivia know is true. Okay, so how would we assess the differences that we've made between these two files? I mean, they're fairly basic, so one way we could do it is just take file 1, output it, and output file 2, and examine the differences by eye. This is easy to do for this small demonstration, but it's not so easy to do on very large files, particularly program files with many lines. They can have many changes. So the tool to take care of this is a program called diff. All diff does is take two files, so let's take file 1 and file 2, compares them, and displays the changes that were made between them in a particular format. So let's decipher this format. Each change begins with a line and change type. So here we have 1C1. On the left side is the line number corresponding to the line in the first file. And then on the right is the line corresponding to the right file. C indicates a change. So we can see that line 1 was changed in the second file, and that line also corresponds to the first line in the second file. And over here we have left angle bracket, which indicates the line according to the first file, a couple of dashes separating, and then a right angle bracket indicating to how it is in the second file. So we can see that there was a change on the first line, and the yellow changed to purple. The second change occurs starting at line 3 according to the first file, and it's an addition, an addition of lines corresponding to lines 4 and 5 in the second file. So these are lines that are not present in the first file, but if they were, they would appear after line 3, and they correspond to lines 4 through 5 in the second file. And this is an additional blank line in the second file, indicated by the right arrow, and then the right arrow is also indicating the addition of a line that says the walrus is Paul. We can issue it in a different format. For instance, I tend to prefer this format, and this format's called unified format. So if I issue the flag -u, it will present me the format in unified format. What this does is present context for the changes. It presents text around, and it also gives a little slightly different output with regards to identifying from which file each line came. So here we can see that file 1 is going to be represented by the dash, file 2 is going to be represented by the plus. It's then followed by a listing of the lines where these changes are going to occur. So in the file 1, it's occurring for lines 1 through 3. For file 2, it's occurring through lines 1 through 5. We can see here that the first line in file 1 had yellow, and the second line had purple. We can see that the line I am the Eggman remained unchanged. And we can see that file 2 had two lines that were not present in file 1. This blank line and then the walrus is Paul. This is the format that you'll typically see in patches for software that's issued on mailing lists or over the internet. So it's good to see it now. So let's talk about another tool. This one's called tar. tar stands for Tape Archive, and what it does is it gathers files together and places them in a containing file known as a tarball. Now, let's say I wanted to gather all my text files in this directory together into one tarball. I can do that by issuing tar with a few flags. I need to issue it with the C flag, which means I'm going to be creating a tar ball. I'm going to issue it with the V, which is verbose, so I can see more of the details of what tar is doing. And then F, which means that the next argument that comes after this is going to be the name of the file of the tarball. So we'll call this mytextfiles.tar. And then we tell it which files we would like to include in the tarball. Well, we're going to want to include all my text files here, so we can do that very quickly using wildcards and star.txt. So if I do this, since I have the verbose command up, we can see which files tar is going to pack into the tarball. So we can see it got all my text files here. And if we list the file, we'll now see that I have a mytextfiles.tar. Let's say I wanted to put this file in the temp directory for someone else to get it. So we can copy mytextfiles.tar to /temp. And now let's go into the temp directory, verify it's there. So I've got my tarball in the temp directory. How do I extract my files from it? Let's have Wallace log in here again. We'll have Wallace go to the temp directory. And let's say he wants to get the files out of this tarball. How would he do that? Well, you issue the tar command again. And instead of doing the C command for create, we use the X command for extract. And we'll use the verbose option. F to tell it what the file, the name of the tarball file is. So it's mytextfiles.tar. If I do this, the tarball is untarred. And if we ls, we can see that file 1, list of countries, my grocery list, all my text files have been taken out of the archive and placed in the current directory. This is the basics of creating a tarball. So these are easily distributable. You can imagine emailing tarball files across the internet of any of your programs that you've written. But before you do that, it's usually a good idea to compress them. So I've got my mytextfile.tar, but I'd like to compress it so it's a smaller file size and more amenable to sending as an attachment for an email, say, or posting on an internet discussion board. We can do this with the command gzip. Gzip will take a file, for instance mytextfiles.tar, and compress it using a compression technique, gz compression. So we've done gzip mytextfiles.tar. Now if we ls, we can see that we've compressed mytextfiles.tar.gz. So let's ls-l mytextfiles.tar.gz to see the file size. Let's make this human readable. We'll feed another flag. Another useful flag for ls is h, which says human readable. So we can see it's a file of size 5.8K. Well, how do we uncompress this file? The answer is gunzip. So if we issue gunzip, my text files tar.gz, we'll see that we have successfully uncompressed the GZ file. And now let's take a look at the new size of this. So we can see that the original tar was 20 kilobytes. Now we can actually combine these in two steps, both for compression and extraction. So let's remove the tarball and reissue this command, but in a more streamlined way. So we're going to create now a tar.gz file using tar, but if we feed it the flag z, tar will use gzip compression upon the tar file to give us a gzipped file. So let's issue that, and then if we issue ls, we'll see we've in one command we've created both a tarball that's also compressed, and we can ls-lh. We can see that it's compressed as well. So let's copy this now to the temp directory. Let's have Wallace go back to his home and copy that file back to his home directory. So here the dot represents copy it to my current directory. So we can see that he has the tar.gz file. He can also, in one step, extract this using tar. So if he issues tar.xv, if he also adds the option z, the file mytextfiles.tar.gz, it will inflate the tarball and also uncompress it before inflating. And now he'll have all those text files.